Hey, what's up? It's Mr. E, your online math tutor, and today we are going to be doing the concluding part of solving systems of equations using substitution method. Now, before you start this video, make sure you go back and watch the part 1 of solving systems of equations using substitution method. That way you understand the 4 basic steps that we need to solve these types of equations. So we have minus 5x minus 8y equals 17, and 2x minus 7y equals minus 17. So let's label this equation 1 and equation 2. So the first step is to isolate either x or y on either equation. It really doesn't matter which one. So let's go with equation 2 and try to isolate the value for x. So to do that, we add 7y to both sides. So now we have 2x. So 7y will cross out, equals 7y minus 17. And then we divide both sides by 2. So x will be equal to 7y minus 17 over 2. So now we've satisfy the first condition, which is isolating either x or y in either equation. So now the second step, we substitute this value into the other equation. In this case, we're going to substitute this into equation 1. So we have a minus 5 for the parenthesis minus 8y equals 17. Now inside the parenthesis, we are going to put in the value for x, which is 7y minus 17 over 2. So now at this stage we have one variable, so we just need to solve for y. So you start that by distributing the negative 5 into the parentheses. So negative 5 times 7y will be minus 35y. Then minus 5 times minus 17 will be a positive 85. And don't forget, it's all over 2. And then we have the minus 8y equals 17. So now, at this stage, I know sometimes it's hard to deal with fractions. So we could get rid of the fraction. And we do that by multiplying the entire equation by 2. Because we have 2 as the denominator here, so as the highest common factor, so we divide it by 2. So when you divide this first expression by 2, all that happens is just the 2 cancels out. So you have minus 35 plus 85. And then when you multiply negative 8y by 2, you have a minus 16y. And when you multiply 2, and this equal to multiply 2 by 17, you get a 34. So now we have a regular linear equation with no fractions. So this is a 35y. So we collect like terms. So we have a 35y here and a negative 16y here. So minus 35y minus 16y will give us a minus 51y. So minus 51y plus 85 is equal to 34. So we could go up here and continue. So we have minus 51y plus 85 equals 34. So now we subtract 85 from both sides. So minus 85 minus 85. So we have a minus 51y equals, this will cross out. So 34 minus 85 will give us a minus 51. So now we'll divide both sides by minus 51. So y will be equal to, so minus 51 divided by minus 51 will be a positive 1. So y is equal to 1. So that's the third step, to solve for either x or y. In this case, we're solving for y. So the fourth and final step we'll plug in the value we have for y into either one of these equations. It really doesn't matter. So we have equation 1 and equation 2. So we could substitute the value for y in either one. So we're going to go with equation 2. So we have 2x minus, put our 7 in the parentheses, and it's equal to minus 17. Now in the parentheses, we already know the value for y as 1. So this becomes 2x minus 7 times a positive 1 would be a negative 7 equals negative 17. Then we add 7 to both sides. So we have 2x, this will cancel out, equals minus 17 plus 7 will be a minus 10. And then we divide both sides by 2. And x will be equal to a negative 5. So in this system of equations, our solutions are negative 5 and 1. And this concludes solving systems of equations using the substitution method. Good luck in your test.